This next section of work is quite important, and it causes quite a bit of confusion, and the confusion is mainly around the wording and the interpretation of what it means. So if we have a look at our last example, that says that based on a sample size of 20 and a sample estimate of 0.7, the approximate confidence interval for the population proportion P is 0.4992 to 0.901. Now that should not be interpreted as there's a 95% probability that the true population proportion P lies within that interval. Okay, because that actually doesn't mean anything. In fact, it's meaningless because our P, our population proportion, is a constant number, okay? And it either does lie in the interval or it doesn't lie in the interval. So the particular confidence interval that we found is just one of many different confidence intervals which may or may not contain the population proportion. And because for each sample we have a different sample proportion, it will depend on that sample proportion. Okay, so our correct interpretation of the confidence interval is that we expect approximately 95% of such intervals to contain the population proportion P. Okay, now what do we mean by that? So whether or not the actual particular confidence interval obtained contains our population proportion is generally not known, okay? But if we were to repeat the process many times, for instance, if we have a look here on the left-hand side, this dotted line down here is our population proportion, okay? And for each sample, we have a sample proportion, so P hat. Now, what we're saying is that 95% of these, in fact, 19 out of 20 of them, this one here does not contain our population proportion, but 95% of the sample intervals that we have taken contain our population proportion. Okay, so the value of our population proportion is indicated by the vertical line and is a constant. Okay, we can see from the diagram that none of the values of the sample estimate is exactly the same as the sample proportion, but that all the intervals except one of them have captured the value of the population proportion, as expected from a 95%. So, for example 8, we expect that the proportion of children in primary schools in Australia who use social media to be somewhere in the range of approximately 50 to 90%, or that 95% of the time the proportion falls between 50 and 90%. Generalizing the approximate confidence interval, so an approximate confidence of 1 minus alpha interval for P is, and what we have is we have P hat minus Z root P hat 1 minus P hat over N and P hat plus. And that would give us our confidence interval, where Z is the standard normal distribution such that P goes from negative Z to positive Z. Okay, and remembering our numbers for our 68, 95, 99.7 and our corresponding Z values, we have 1.96, negative 2.58, and 1.64. In the next example, we'll have a look how we interpret these.